Hello ladies and gentlemen, welcome to my YouTube channel. Today we are going to have a revision on ZIMSEC typical practical question on liquid pressure. This is under physics section. You can apply the knowledge also if you are studying pure physics. So first I'm going to explain a simple experiment that is done on liquid pressure. The first step is you need to take a plastic bottle. You punch 3 holes on each side in the same direction but at different heights. This is shown in Fig 4.1. We can see these 3 holes which are punched in the same direction at different heights. After that, you need to pour some water into it and let it flow through the holes and observe the flow of water. So this is what you are going to observe. Water come out from all the holes with different force and falls on the ground at points that are variable distance from bottom. Water from the lowest hole, which is number 3, is going to come out with the greatest force and falls at a point that is maximum distance from the bottle. And then the water that is from the topmost hole, which is hole number 1, it is going to come out with the least force and falls at the point that is at the minimum distance from the bottom. So this is the conclusion for this experiment. This activity confirms that the pressure in liquid varies with the depth of the point of observation in it. So now let us attempt the questions. So the question is reading, Fig 4.1 shows an experiment set up to investigate one aspect of liquid pressure. On 4a part 1, we are supposed to suggest how a continuous supply of water was provided in this experiment. So it was provided by keeping water from the tap running into the apparatus. Let me repeat to explain again. Continuous supply of water was provided in this experiment by keeping water from the tap running into the apparatus. On Fig 4.1, show the water movement from holes 2 and 3. They have demonstrated the water movement from hole 1. So we are supposed to show the water movement from hole 2 and hole 3. So from the hole 3, it is going to move a further distance, followed by hole number 2. So this is what we are going to present on our diagram. The stream 3 is going to move the furthest distance, followed by the stream number 2, and then the last one is stream number 1. And then on part 3, we are supposed to draw a conclusion from this experiment. So the conclusion is that pressure increases with depth, or we say pressure is directly proportional to depth. As depth increases, the pressure also increases. Activity confirms that pressure in liquid varies with depth. Pressure is directly proportional to depth. As depth increases, pressure also increases. Let us move on to the next question. Part B is reading, in another experiment, a pupil set up apparatus as shown in Fig 4.2. On B part 1, we are supposed to state what would happen to the value of H if the funnel were moved from position X to position Y. So we can see the position X, it is the one that is below, and then the position Y is the one that is above. So previously, we concluded that pressure increases with depth. As the depth increases, pressure is going to increase also. So here, if we are going to change to move the funnel from position X to position Y, the value of H is going to decrease. On part 2, we are supposed to explain the observations made in B part 1. Pressure decreases as funnel moves up. This is going to result in less water pressing on funnel at Y, decreasing the value of H. And then on part 3, we are supposed to suggest what would be observed if the funnel were moved sideways but at the same level as X. We're supposed to explain the observation. So there's no change that is going to occur in level H. This is because pressure at the same depth is equal. Let us move on to the next question. On part 4, we are given that the height of water, which is H, was 0.5 meters. The density of water was 1,000 kgs per cubic meter. And acceleration due to gravity is equals to 10 meters per second squared. We're supposed to calculate the water pressure using the formula pressure is equals to height times density times acceleration due to gravity. So our height is 0.5 meters. We are going to substitute that 0.5 meters. And then our density is 1,000. So we say times 1,000. And then our acceleration due to gravity is 10. So we are going to multiply by 10. We need to find the value of 0.5 times 1,000 times 10. We are going to obtain 5,000 pascals. Pressure is measured in pascals. So we are going to write 5,000 pascals, or we can write 5 kilopascals, because if you convert from pascals to kilopascals, we are going to divide by 1,000. So 5,000 divided by 1,000 is equals to 5. So either we write 5,000 pascals or we write 5 kilopascals. In the preparation for your practical exam, make sure you are familiar with this experiment on liquid pressure. You are able to design the experiment. You are able to come up with perfect conclusions. We are able to calculate pressure in liquid and to know the instruments that are used to measure liquid pressure. This marks the end of our tutorial today on ZIMSEC typical practical question under liquid pressure. Thank you so much, guys, for following me on this channel. Please don't forget to subscribe, like, and share my videos. I love you all. This is Eve signing out.